Hello. In this video, we will discuss about some of the reactions of aldehyde and ketones. Okay. Aldehyde and ketone poses the common functional group, that is C double bond O or carbonyl group. In aldehyde, the carbonyl group is attached on one side with R group and the other side with hydrogen, whereas in ketone, the both sides of the carbonyl group poses some alkyl or aryl group. Since they have common carbonyl group as the functional group, most of the reactions of aldehyde and ketones are similar. Among these different reactions, the major reactions of aldehyde and ketones are we call the nucleophilic addition reaction. So in functional group carbonyl group, the oxygen is more electronegative, therefore it poses slight negative charge, whereas carbon is slightly positive. Now, in such type of the polar carbonyl group, a nucleophile, the species having either lone pair of electron or the negative charge, will attack on the carbonyl carbon. Okay, and once it attacks, the pi bond from the C double bond O will then move as the negative charge on the oxygen. So the result is R C now becomes single bond O with a negative, and it has on hydrogen for aldehyde or R prime for ketone. Now here on the carbon nucleophile Nu is attached. Now, since it has form O negative, it can pick the proton from the solution and then will convert into OH. In this way, in the nucleophilic addition reaction, we have attached nucleophile on one side of the on the carbon, whereas the hydrogen is attached to the O, making it OH. So you have it as hydrogen and the nucleophile. This type of reaction, we call that as the nucleophilic addition reaction. This is the most common type of the reactions that aldehyde and ketone undergo. Among this category, one of the most important reactions that we need to discuss here is number one, we call that as the Wittig reaction. It's a very popular reaction, very important examination point of view or understanding point of view as well. Now, the Wittig reaction is a key reaction. It's a key reaction to convert carbon oxygen double bond to carbon carbon double bond. So the oxygen will be replaced by carbon. Okay, and it in this reaction it uses a special type of the reagent called phosphorus Y-lide. So that is what we will be discussing. So let us try to talk a little bit about the reaction. In this case, say for example, you have RC double bond O. It can be aldehyde when the attached group is hydrogen, or it can be ketone when the group that is attached is R prime. Now, we wanted to convert this aldehyde or ketone, the C double bond O group of aldehyde and ketone, to carbon double bond carbon. So say H or R as it is, or R prime. Now C double bond O we would like to convert to C. Now you can have any two group on this carbon. Say for example, one side we use 1, 2, 3 propyl group, and other side we group series methyl group. So this is what we wanted to make. That means the oxygen we wanted to replace by this group here. Now, in order to this is what we call the Wittig reaction. So double bond O is replaced by double bond C with two group on carbon. Now, in order to achieve this, what we need is, again, as I said previously, we need what we call phosphorus Y-lide. So how does it look like? The phosphorus Y-lide, so it will be attached. We will be discussing that in detail in this reaction here. Again, this is the reaction called Wittig reaction. For the phosphorus halide, you need to remember that it will have triphenyl phosphine PPS3. By the way, this PPS3 is phosphorus will have the three benzene ring attached to the phosphorus. That is called triphenyl phosphine. Triphenyl phosphine. Now, as you know that the phosphorus can form up to 5 bond. So this triphenyl phosphine that is with the positive then will be attached with the carbon, and it will have the carbon has in whatever group that you need to incorporate on the for the C double bond O, that is what you wanted to put with the carbon. So the in our case, one side is methyl and the other side is 1, 2, 3 carbon propyl group. So the triphenyl phosphine is with plus and the carbon is with, since it has only 3 bond, it will be negative. This is what we call is the phosphorus halide. Again, the key part to be understand here is triphenyl phosphine, which the structure, this is the triphenyl phosphine, it is written as PS3P, triphenyl phosphine, PPS3 or PS3P. Triphenyl phosphine attached with the carbon that poses two group, whatever group that we wanted to incorporate in our alkene product, those are the two group that you need to attach here, and this carbon will be negative because it has only 3 bond. Okay, now there are two things that we need to discuss. First of all, what is the mechanism of this reaction? How does the reaction takes place? That is one part. And the second part is then how do we prepare this phosphorus halide? So let us discuss them one at a time. First of all, we will discuss what is the mechanism of this reaction. Okay. So in this case here, let us use this RC double bond O, either H or R prime. Again, it is both for aldehyde and ketone. Now we have the phosphorus halide. So in this case, again, we have triphenyl phosphine PPS3 with a plus, and this is the carbon with one methyl group and other is propyl group, and this carbon is negative. Again, I'm copying this halide as it is here. Now I wrote in this format because in this case what happens is carbon is with negative, this negative, then will attack on carbonyl carbon because it is slightly positive, the oxygen is slightly negative, so the negative carbon will attack on carbon. At the same time, this oxygen now will possess negative charge. So our structure, now this is where we need to be very careful to draw the product here, right? In intermediate product, so to say, this is carbon which has hydrogen or R prime, depending upon whether you are using aldehyde or ketone. Now this will be bonded with other carbon that has one methyl group and other is propyl group. And this now is bonded with what? Triphenyl phosphine with a plus. At the same time, this oxygen now has negative. Now you can see very clearly that O minus and P plus, phosphorus with the plus, they are staring at each other. So that is when they will form a bond, right? And it will form the four-member ring structure. That is what we call betaine, okay, the intermediate. So R, C, H or R prime, depending upon aldehyde or ketone. O minus will then bond with PPS3. This is your plus and this is minus. It has here carbon as it is, and you have propyl group. So this is bonded there. This structure, this intermediate structure that is formed is called betaine. Okay. Now this, the phosphorus love oxygen. So that is when this four-member ring will break in such a way that the oxygen will go with phosphorus. This bond will break and oxygen will go with phosphorus, and this carbon carbon will form the double bond. Result is, then we have our product. We have R C H or R prime, and here carbon carbon now is double bond with one is methyl group and other is three member like propyl group. So this is how we will get our final product. So this is the mechanism of Wittig reaction. Now the next part that we need to discuss very clearly is, okay, we understand how the betaine is used to for in the Wittig reaction. The question is, where does this betaine come from? Okay, again, now for the formation of betaine, that again we have used the betaine here is triphenylphosphine PPS3 with a plus, which is bonded with carbon, and one is methyl group and other is propyl group with a negative. So we wanted to learn this Y-lide. How do we obtain this? How do we get this? Okay. Now, in order to prepare this Y-lide, so again, we have, first of all, we need to have the triphenylphosphine PS3P. Triphenylphosphine, as I wrote the structure previously, three benzene ring attached to the phosphorus. You have 1, 2, and 3 benzene ring attached. So that is what we call PS3P. It is written like this. Now you know that phosphorus will possess the lone pair of electron. Now this then will react with, so you have carbon and one is methyl and other is propyl group, and you have to have one hydrogen, then other, the starting material needs to have hydrogen and other some halogen. Say you can use bromine or chlorine or iodine as a leaving group. So this is the component that you need. So what are the things needed? Carbon with whatever group you wanted to put, two of those group, and other one has to be hydrogen and one has to be halogen, chlorine, bromine, or so on and so forth. So what happens is these two then will react to by the SN2 mechanism with the bromine leaving. In this way, this triphenylphosphine then will attach with the carbon, and you have one methyl group and you have that propyl group, and of course there is hydrogen. Now since this phosphorus has given the lone pair of electron, this will form a positive. Now at this point, our only job needed is to take away this hydrogen and make negative. That will be our strong nucleophile. So in order to take away this hydrogen, what we need is, you need a very powerful base. You remember this base, it is called butyl lithium. Butyl will be negative, lithium will be positive. That will, this negative will then grab the hydrogen. So this will grab the hydrogen and will form the negative. In this way, triphenylphosphine would be positive with the carbon, one bond here, and then one group, that is propyl group in this case, and this will be a negative. So this is how we prepare the Y-lide. This is how the Wittig reaction takes place. Now this reaction is very, very popular reaction. Say for example, now one open-ended question that we can make is, suppose we have here 5-member ring and double bond. We wanted to put some kind of group. Say for example here butyl 1, 2, 3, 4 butyl group with a carbon. This is what we wanted to make. This is our ultimate goal. Now, how can we use Wittig reaction to make this? So this is what we need to do. You just break this in the middle, wherever there is a double bond, and one portion will come from the aldehyde or ketone. Basically here is, say for example, double bond O. And the other part of this on the side, that will come from the Y-lide. So this is with the carbon, one is the methyl group, and one is 1, 2, 3, 4 carbon chain, 1, 2, 3, 4 carbon chain, and it needs to be one with the hydrogen and one with the halogen, bromine, chlorine, and so on and so forth. And this is the reagent that will create the Y-lide. How does we create the aldehyde?